And so let's move on. Everybody's wondering about my beads. You notice my beads? I call these the beads of Wiatangi, but I have to be honest with you, that's my contrivance. I ran an article in the newsletter, and no one read the last sentence. Or essentially, some people didn't read that, and they're all upset with me because these weren't built by the Maoris. No, they were built by Chuck Missler. They're a replica. But anyway, the issue is I happen to call them for the... See, well, I'll explain in a minute. We have the beads of Wiatangi. What this is, it's Genesis chapter 1, verse 1 in Morse code. Those of you at radio hams would recognize this. You got did it, which is I, dot it, which is in, and da, which is T, the. 4 dits, that's the H. 1 dit is E, the, T-H-E. In the beginning, God created the heaven and the earth. Isn't that cute? Now, the question is, the reason I did this, it's not original with me, but that's another whole thing. Question is, see, the way I usually tell the story is I spilled a bunch of black and white beads on the floor, and I picked them up randomly and put them on this thread. And guess what? It came out to be Genesis 1:1 in Morse code. How many of you believe that? Now, the reason you're laughing is because you instinctively know that that's absurd. In fact, I want to remind you of Lewis Carroll, Alice Through the Looking Glass, when she encounters the Red Queen, remember? And she's being chided because she doesn't believe in impossible things. Alice says, one can't believe in impossible things, Alan laughed. I dare say you haven't had much practice, said the Queen. When I was your age, I always did it for half an hour a day. Why, sometimes I believed as many as 6 impossible things before breakfast. Now, if you know Charles Dodson's spoof here, it's a very mathematically oriented spoof, what we treat as a children's story, but there's some very subtle things here that are very profound. And that is the way we force our kids to believe impossible things. Now, the origin, did you think this thing occurred through random chance? No. The story I usually weave, see, bear in mind, February 6th was the birthday of New Zealand. So I couch this whole story as if it was the Maori people, the Aborigines. Did they know Genesis 1:1 in English? Did they know Morse code? Well, see, it happens that you got an alphabet of 2, black and white. It's alphabet of 2, right? And it takes 347 beats to do this. So the probability of this thing happening by chance is 2 to the minus 347th power, or 2.8669 times 10 with 104 zeros after it. Now, the reason I mention that mathematically is in mathematical physics, 10 to the minus 50 is defined as absurd. Any probability that goes beyond that is defined as absurd. They have to have a cutoff. This goes 10 with 50 zeros times that much. In other words, 10 to the 104th is a big, big, big number. There's only 10 to the 66th atoms in our galaxy. That's a big number. Now, I want you to contrast. You wouldn't expect your children to be taught this happened by accident, right? And this is just a binary string of 347 beads. What about your hemoglobin molecule in your body? You see, that consists of 574 elements taken from an alphabet of 20. Its probability of being that particular sequence of amino acids is even more remote than this. In fact, you've got an alphabet of 20 amino acids. You're going to pick these particular numbers, 36 of those, 68 of those, et cetera, to make up the hemoglobin. The specificity we're dealing with here, there's a formula for, I won't bore you with, but it's 10 with 650 zeros after it. Yet we teach our kids in school, or we allow our government schools to teach our kids that this happened by accident. And yet you wouldn't think of promoting the fraud that these beads happened to be accidental. And by the way, of the 10 to the 650th power, those permutations, only one of them is hemoglobin. Any others typically lead to hemoglobinopathy, which is fatal. So it's not random at all, of course. Now, there are only 10 to the 18th seconds in the history of the universe if you assume the universe is 15 billion years old. That's only 10 to the 18th seconds. There's only 10 to the 66th atoms in the galaxy. Only 10 to the 80th particles in our entire galaxy. So the probabilities of 10 to the 50th are defined as absurd. And so obviously the specificity of 10 to the 650 goes way beyond any possibility of chance. Now, dramatize this in ways that you and I might be able to relate to more. 10 to the 650 power is equal to winning the lottery Not just once. That's we understand one chance in what, 80 million. Not twice in a row. What's the chance of winning the lottery 3 times in a row, or 4? Well, this is equal to winning the lottery every day for 90 days. Those of you that think that's even a possibility may leave quietly. Yeah. Okay. Now, I, of course, contrasted what about our DNA? I'll throw this in quickly. I won't get into a whole thing here, but I can't resist getting into this. We've been talking simplex alphabets, but there are such things as error detecting codes that intrinsically will detect if there's an error in the transmission. There are error correcting codes. You can make computers with cards that you can actually pull the cards out while it keep running by using not 8 bits per byte, but 11 bits per byte. And there are adaptive coding schemes where the coding scheme will adapt to the syntax. In other words, there's sophisticated levels of code that probably not one engineer in 10,000 has the skill to design these things. Now, the DNA code turns out to be a 3 out of 4 error-correcting, self-replicating code. And that is a real design challenge. And you're talking over not 347 elements, 3 billion elements that define the manufacture and arrangement of hundreds of thousands of devices in our body. These consist of unique assemblies. They're selected from over 200 proteins, each involving over 3,000 atoms in 3-dimensional configurations, and all defined from an alphabet of 20 amino acids. And amino acids all look differently, but they have a common connector, and they lend themselves in chains. There's 20 of them that make up life. Most of you that some biology are familiar with these. And some of them are hydrophobic or non-soluble. The other half are hydrophilic or very soluble. Of these, 3 of them are basic, and 2 of them are acidic. And that out of this alphabet of amino acids, all proteins are generated. And the negatively charged groups, anyway, their characteristics determine the 3-dimensional shape they take once they're made into a chain. And I won't get into this further, but the DNA is an alphabet of 4 choices. And with those 3 of those 4 choices, you can define any one of these amino acids and also the punctuation, the stop and start bits and so forth. Another way to represent it, which may be clearer, let's not spend a lot of time. The messenger there's a messenger form of this, which has one letter slightly different, but you and I, we won't try to mispronounce all these names. A, U, G, C are the letters. It turns out that if you put these together, they naturally attract matched pairs. And so if you separate this, the missing matched pair will join it. So this thing is intrinsically self-replicating. It can copy itself by the use of these complementary pairs. This design job is incredibly skillful, and yet our culture would have us believe this is all part of a random process. And you take the messenger RNA, and it generates a machine that will read this like a recording head reads a tape recorder. And it moves along, and as it reads the code, it knows which protein to add to the chain. And with this, it converts that code in the master record, a copy of the master record, into the proteins required. Thousands of different kinds of intricate machines. Each one is a design challenge. And the question isn't which came first, the chicken or the egg. The question is which came first, the protein or the DNA. You can't have the DNA without